Did you know that communication is actually one of the most important things in science? As we discover cool things, we need to be able to share them with others. And when we're talking about data and measurements with other scientists, we need to make sure we're on the same page. So, how do we do that? Well, one of the ways is to use units. We use units whenever we talk about things like position, where an object's located, how long it is, its mass, how much matter it's made up of, or its motion. How is that object moving? You probably hear units every day. For example, you've grown, let's say, 1.5 inches in the past year. Or that tree over there is 25 feet tall. And maybe you went swimming in a 25-meter pool. And we're just going to pretend that the pool is a rectangle because, as you can tell from my tree, my artistic skills are not that great. Anyway, this brings up a super important point about why we use units. I just used 3 examples of length measurements with 3 different units: inches, feet, and meters. Imagine if I didn't attach a unit to any of these measurements. You grew 1.5 meters? Whoa! 1.5 hands? Well, whose hands? Your hands? Or my hands? Oof. Well, pretend those are hands. Units let us know how much of a quantity there is. So a meter is always used to measure length, and we know exactly how long a meter is. That way, when we say something is 2 meters long, no one has to guess at how big that is. Any measurement or data point always needs to have a unit, or else it's just a meaningless number. To avoid any confusion, in science we use what are called SI units. SI units are the International System. Could there be any more letters in this word? System, used by scientists all over the world. We'll use meters to describe position or length, kilograms for mass, and if we're talking about the motion of something, meters per second. And while this is the agreed upon scientific unit system, you should be aware that other systems do exist, which means things can very easily get very confusing if you forget your units. And you might be thinking, oh, come on, who mixes up units? Well, it happens more often than you think. Even rocket scientists have done it. I mean, a Mars orbiter actually crashed due to a mix-up in units. No, seriously, that actually happened. Look it up. And remember to use your units. When we make new discoveries, we need to be able to share them with others. And the first thing we have to do is make sure everyone is on the same page. We do this by using units and frames of reference, which are also called reference frames. We talk about units in another video, so let's look at what a frame of reference is. Let's say this blue box thing is a car, and it's going 45 miles per hour. Someone standing on the side of the road would see it pass at 45 miles per hour. Now, if this yellow truck is going 40 miles per hour, someone sitting in the yellow truck would observe the blue car traveling at 5 miles per hour. How could the person on the side of the road see the blue car traveling at 45 miles per hour and a person in the yellow truck see the blue car moving at 5 miles per hour? This is because both observers are using different frames of reference. So let's go ahead and take a look at that, starting with the speed of the blue car. The person on the side of the road is using their frame of reference of being at rest. So relative to them, the blue car is moving at 45 miles per hour. To the person in this yellow truck, which remember is already going 40 miles per hour, the blue car is going 5 miles per hour. Now let's do the exact same thing for the speed of the yellow truck. So what is the speed of the yellow truck for the observer on the side of the road? It's 40 miles per hour. And what do you think the speed of the truck is for the person using their blue car as the reference frame? Well, the blue car is moving at 45 miles per hour and the truck is only moving at 40 miles per hour. So the speed of the yellow truck is actually 5 miles per hour slower than this reference frame because the blue car is already moving at 45 miles per hour. Now, you might be thinking, but wait, the person on the side of the road isn't really at rest. They're on the earth and the earth is moving. You're completely correct. The person is at rest with respect to the earth, and the earth is the most common frame of reference that we use. To an observer in space who is not rotating with the earth, the blue car is going 45 miles per hour plus the speed of Earth's rotation. And this is why frame of reference is so important. We just talked about one blue car having 3 different velocities depending what the frame of reference is. How would we communicate this to avoid confusion? Well, we state the reference frame we're using. The blue car is moving at 5 miles per hour with respect to, which I'll write as WRT, the yellow truck. This tells us that the yellow truck is our frame of reference. Or we could say that the yellow truck is moving at 40 miles per hour and the blue car at 45 miles per hour with respect to the earth. That way, everyone is on the same page, a page which, to be clear, is in a book that, relative to me, is at rest.